Good morning. It's Friday, eh? Good morning. That's better. All right. Close to the weekend. All right. So, welcome to the first talk of day 2 of the conference. I'm doing 2 talks here today. This one, the next 60 minutes, we're going to be talking about some architectural stuff regarding enterprise mobile applications built with Xamarin.Forms. We're going to take a look at a whole setup, starting with a mobile application built in Xamarin.Forms. Then we're going to move to the backend, where we have a microservices setup built entirely with .NET Core, running on Docker. So it's it's a nice setup that I typically use for the applications that I build at customers as well. My name is CLEEREN. I'm coming from Belgium. It's the first time here in this lovely country, lovely city. Very nice. Saw it yesterday. Looks very good. Going to explore it during the rest of the weekend. So thanks for having me. I work at Xamarin in Belgium, which is a high-level consultancy company that we have set up very recently. If you have any questions after this presentation, feel free to ask them after the session, because we have quite a lot of things to cover, so I'm not going to be able to answer them during the talk. But feel free to send me an email afterwards, check my blog, send me an email, or contact me on Twitter. That's fine as well. I also do a lot of Pluralsight. It's good news for you that this presentation, which we only have about 50 minutes to cover here, well, it is actually available also as a Pluralsight course that takes about 4 hours, I think, 4 or 5 hours. So there, of course, I go a lot deeper in everything that I'm talking about here. So check out the link. I have quite a few Pluralsight courses on there as well. And if you don't have enough hearing me talk, if you can't get enough of hearing me talk, I also do on-site presentations and on-site training on this stuff. So what are we going to be doing today? Well, as mentioned, I'm going to start by giving you an overview of the overall application architecture, and then we're going to dive in the Xamarin.Forms part. That is going to be the meat of the presentation. That's where I'm going to spend most of the time. I'm going to show you how we can set up a maintainable, testable Xamarin.Forms application architecture built around MVVM, dependency injection, loose coupling. We're going to see how we can do messaging and that sort of thing. Then we're going to move to the backend, where we have a setup built entirely with .NET Core, a microservice setup that is running inside of a Docker container orchestration. So that's basically the whole setup of what I have planned for you today. So let's not waste any time. Let's directly take a look at what we are going to be looking at. I'm going to show you, I'm going to start with an overview of the solution structure. I'm also going to show you the running application, and then we can dive into the code. So what are we going to be looking at? Well, the setup of the application is basically this. On the for you on the left, for me on the right, if I stand this way, we have the client-side stuff. Well, one of those clients is the one that we'll be looking at. That is the Xamarin.Forms application. It is one of the different front ends that is based on that same backend. And we, of course, as mentioned, are going to be spending time looking at the Xamarin.Forms mobile application. The Xamarin.Forms, as well as the other clients, are going to be connecting with a microservices backend. That was what you see there on the right. Microservices typically do one thing and one thing only. And that's the promise, let's say, of microservices. And here you see that we have a couple of microservices, one around ordering, one around identity, one around the basket and that sort of thing. That is, of course, also the scenario that I'm going to show you in just a minute. You also see that we have an MVC application, which, by the way, is also hosted inside of a Docker container. That's the one here in the middle. That's basically responsible for the generation of the HTML frontend, and then we also have an Angular application that is talking with that client service, that microservices setup on the right. So let's start by taking a look at the running application, so that you have an idea of what we will be working with. So this is the application, not impressive. You may have seen this. The application that I'm using in this demo is not an application that I've built myself, but I've built my applications basically almost the same as this one. This is actually a sample built by Microsoft. Maybe you've seen it. It's eShop on containers. You can actually get the source code for this via microsoft.com/net/architecture, where they actually also use more or less the same setup as that I will be using here today. So the Xamarin mobile application is really nothing fancy. It's like a small store front end, allows you to browse through some products here. It's a product catalog. We can add one to the basket. Maybe you have seen that it actually has increased the number of items in the basket. It went to 3. When I click this again, it will increase to 4. That's the typical promise of a shopping basket, I think. It has this, so we can click on the basket, and then we can go to the checkout, and then we see the products, and then we can order them. Well, really nothing fancy. That's not what we're here for. We're here to talk about the architecture of how this entire thing is set up. All right. So let's take a look at Visual Studio. And I know the Solution Explorer is going to be small for you, so I'm going to zoom in, of course. I'm not going to make you squint throughout the next 60 minutes. I think this is really pretty much visible. Let's zoom in a little bit more. All right, so if we look from a high-level perspective at the application, or the solution structure, I should say, as you see, we have the mobile apps. That's nothing to be amazed of. That is the Xamarin applications that we'll start exploring in just a minute. Containing shared code, that's the promise of Xamarin.Forms. A lot of shared code. In fact, in this application, I think easily 90 to 95% of the code is actually being shared. So that's the shared code. We'll start exploring that in just a minute. Then we have the applications, the actual Xamarin.Forms applications, actually not Xamarin.Forms, the native Xamarin applications, the Android, the iOS, and the Windows UWP application. Then we have the web services, so the APIs. That's the microservices set of functionality. We have a service for the catalog, we have one for identity, we have one for the basket. So each part of the functionality of this application is built as a separate microservice. And then we also have the different web apps. That's what you see down here at the bottom. The MVC application, that's the old school MVC application. I have the SPA built in Angular, which is directly going to talk with the web services as well. And the status is actually a separate website. And all of this is basically being managed when it's being deployed via a Docker file, as a Docker orchestration file. That's the file down that you see here at the bottom. If we have time, hopefully we'll take a look at that by the end of the presentation. So typically this presentation takes about 75 minutes. I was a bit amazed that I only had 50 minutes. So if you want to skip the break, I can do that. All right, so that should give you already a high-level overview of what we are going to be exploring. And as mentioned, we're going to start by looking at the Xamarin.Forms part. Now, talking about Xamarin, I always emphasize that people should be using the MVVM. The MVVM pattern. MVVM stands for Model View View Model. It's nothing new. It has been around for quite some time. And it is, in fact, a pattern that will help us build more testable, more maintainable applications. That's what we are going to be striving towards. It has been around for quite some time in other formats. It's basically pretty much the same as MVC, which is an evolution of the presentation model by Fowler. So it's really nothing that fancy. And a lot of people are scared MVVM seems to be complex. Well, it's far from complex. Now, it's really something that became popular with XAML, because XAML offers you data binding, offers you commanding. That's also what we are going to be using here in this presentation. This is basically what a lot of people have been doing, writing XAML applications all the time with code behind. Now, code behind is really nothing wrong with it, apart from the fact that the code that we are building is pretty much untestable and very hard to maintain in the long run as well. So this is the schema that you get with just code behind. You have a lot of XAML, and then you have the code behind, and the code behind is really the cause of all the problems. Because on one line in the code behind, you're going to go to the data model. The next line, you're going to be updating the UI, and that code, well, that is by default hard to test. That's not what we want. We want to have enterprise applications. We all know that they are going to be changing quite a lot over time, so we need to make them testable and maintainable. That's what we are going to work towards. With MVVM, we are going to basically introduce another layer of abstraction. And a layer of abstraction is the view model. Well, this is basically the schema that we are going to be working towards when building an MVVM-based setup. You're still going to have the XAML. That hasn't really changed. You're going to have a little bit of code behind. That code behind is, well, it's limited to doing things directly, purely with the view. So setting the focus, changing a color, that's okay. But nothing that has to do with the model. Because we have actually added another layer of abstraction here. That's what you see here, and that's the view model. That's the one here at the bottom. And the view model is going to be responsible for a couple of things. It's going to expose state, data, and operations. Those are commands, and we'll take a look at those in just a minute. It is going to be the view model that directly talks with the data model, and not your code behind anymore. There's no direct link between the code behind and the data model. The data model is going to be invoked, it's going to be questioned by the view model. Give me some data, that's going to be state, and then the view model is going to change, and it's going to raise a notification towards the view, and the view is data bound on the view model. And that's a little piece of magic, of course. I'm not going to explain you how data binding works. We don't have time for that, so I hope that you're already pretty much familiar with that. But the view is going to be data bound on the view model. And we're going to use data binding for data, for state, and we're also going to use that to work with operations, so with commands. This is the promise of MVVM and how an MVVM setup is going to work. It is going to be much more testable. We are going to be working on separate things. If we change the UI, we don't really have to change the view model and vice versa. That has a lot of positive impact because we don't have to, we don't create a lot of impact when changing one thing in other layers as well. We're going to create a nice separation of concerns, and we're going to introduce more loose coupling, which is one of the big promises of MVVM as well. This is what the view code is going to look like. The view code is just going to be purely XAML, which is data bound. This is a couple of samples. You see here, for example, I'm going to look here. There's an entry. So that's Xamarin.Forms text box. That is going to be bound to, in this case, username.value. That's because there's, in this sample, I'm not going to be able to show that, but there's validation going on. That's why it's username.value. And the label, as you can see, is going to be bound to a couple of errors. If there's any errors, we're going to show them. And we're going to also use a list view in combination with data binding, where we set the visible property, the isVisible property, to the campaigns.count, which is going to check if there's any campaigns, and otherwise we're going to hide the list view entirely. And the item source is also simply data bound. And where is this data coming from? Well, the data is coming from the view model. That's where it's going to come from. And what is the view model going to look like then? Well, as mentioned, that's a simple class that is going to do two things. In fact, there's a third thing. I'm going to come to the third thing later on. But the view model is just a class that exposes state and operations. Data, state, and operations commands. And it is going to be the target for the data binding of the view. So the view is going to data bind on that. So it does need to notify the view about any changes that have happened. That's why, in this case, it is directly implementing an interface called the iNotify property changed interface. That's an important interface because that's what data binding is listening for. There's an event going to be raised when the view model state is going to be changed, and then the view will automatically update its state as well. So that's what MVVM looks like in a nutshell. Again, there's much more to tell about MVVM itself, but we don't have time to explore all of that here. So let's take a look at how the MVVM pattern is implemented in the application. So I'm going to zoom in directly into the shared code. So let's collapse all the rest. So everything that I've just already briefly explained is going to be located directly in this core project. So let's see how we can get some data into the UI. So we're going to start with the models. The models are all here. By the way, I always get questions from people, should we actually put everything in one project, or should we split it up, like the models in a separate project and the view models in a separate project? Of course, that works fine. In a real-life application, I actually might do that as well. Here it is just placed in one big project. It might make sense to actually split it up because then you can expand to reuse if you use .NET Standard, maybe to also reuse the models and that sort of thing in other technologies. All right. So here we see the models. The models, for example, include, well, the catalog item. The catalog item is really the product. And as you can see here, that's your plain POCO. There's nothing really fancy going on with the model. It's just plain classes. And we'll see how they get their data later on when we look at the services. Oops, I shouldn't zoom out. There we go. So the models are being used in this case by the services. Again, we'll explore the services in much detail later on. But you can already see that the services have this get catalog async, for example. That's the catalog service. It's going to return a list of catalog items, an observable collection, I should say, of catalog items. And where is this going to be returning that to? Well, the services are going, that's the model, and they are going to be invoked by the view model. Well, let's take a look at the view models. They are, surprise, surprise, located in this view models folder. For example, if you look at the catalog view model, we're going to see that the catalog view model is doing a couple of things. It's inheriting from view model base. I'll come to that in just a minute. But as mentioned, it does two things. It exposes state and operations. This is the view model that powers that screen with the products. So what should it expose as state, as data? Well, it's going to expose this products list. There's a products observable collection that the UI is then data binding to. That's basically what is happening. The view model is also exposing commands. And the commands are a bit lower in this thing here. We have a couple of commands, and we'll talk about commands. If those aren't clear for you, just don't worry, we'll talk about them. But commands are basically your operations that the view model is exposing. Things that we used to have in code behind, in click event handlers and that sort of thing, we don't have that anymore. If you look at the code behind for the screens, I will do that later on when we look at the views, they are pretty much empty. We shouldn't be doing anything that has to do directly with the model in this case. So that's what we see here. State and operations are being exposed as properties on the view model. The view then, if we go all the way up to the view, let's go to that catalog view. We'll see that the catalog view, sorry, There we go. The catalog view, there's a lot of XAML going on here. So scroll all the way to the bottom. That's things like styles and stuff that we see here at the top. And we have this list view, which is indeed setting its item source bound to products. Now we'll see just a minute how they're actually linked, because the view model does need to know about the view, but that we'll talk about very soon. So that's basically end-to-end how the different layers are being set up. Let's go back to the slides for just a minute, and we'll come back because I have a couple of things to explain first. So what do we have next? Well, we do need to have notifications. The view needs to know that the view model has changed, because the view model is going to go out to the data source, so the model, and the model is going to perhaps raise an event. Hey, it's some new data, and then the view model needs to notify the view about these changes. Well, how is it going to do that? Well, we're going to use the iNotify property changed interface, as I already mentioned. Now, in the view models that we had in the application, we didn't really have the iNotify property changed implemented directly. Now, instead, we have this extra layer. You saw the view model base. Well, there's actually another base class on top of that, which is called the extended bindable object. Now, instead of talking about it here to save us some time, let me go back to Visual Studio directly and take a look here at what is happening to let the view and the view model, let's say, communicate. Well, let's take a look at the catalog view model again. And as you can see, we have this view model base here. And the view model base, if we do a go to definition, we'll see a couple of things. There's a base class, of course this is a base class, which does one important thing. There is this initialize async method, which is virtual. I'll come to that method later on when we look at navigation, because this is an important one, because it will actually be responsible for lazy loading. We'll come back to that one in just a minute. The other base class is the extended bindable object. And that has this raise property changed method. In this case, it's using this expression function of t. You can basically do this another way. The most important thing is that you are going to invoke onProperty changed. Now, onProperty changed is defined on the bindable object, and the bindable object is actually a class that is implemented directly in Xamarin.Forms. It is your dependency object, really. Dependency property implementer and the base object in MVVM. So this is what we get here in Xamarin.Forms. The bindable object is implemented by everything that is going to be bindable directly in Xamarin.Forms. And it also has this onProperty changed over here, the property changed, which is going to be invoked by our bindable object. So if we go back to the catalog view model, and for example, when the products have changed, we are going to call this raise property changed method, which then in turn call that raise property changed on the extended bindable object, which will then invoke the property changed, and then the view model will get or will raise a notification about the view for the view, so that it will automatically update. So that's how the two keep in sync and remain synchronized. Okay. Now, the view model has one more important task, and that is making sure that we don't have to write any event handlers in the UI anymore, so that we don't have to click on something and handle that in the code behind. We also want to make sure that we don't have to write any code behind. And then we again think of moving all the functionality of when a click is happening or an item is being selected in a list view. We also want to move that functionality into the view model. And how can we do that? Well, then we have to look at commanding. Now, commanding in itself is a pattern that really doesn't have anything specifically to do with MVVM. It is just going to say that we're going to create a type that is going to contain all the information to talk or to wrap the information to invoke something later on. And that's exactly what we're going to do here. MVVM support, so Xamarin.Forms supports the iCommand interface. And the iCommand interface is going to be used to create an object that contains all the information about an event being invoked in the UI, and that we can handle that later on. That's what a command will allow us to do. The iCommand interface is a pretty simple interface. There's three things. Two are very important. That's the execute method that is going to be used to specify which work we want to do when something has happened in the UI. And the can execute boolean is actually going to be used to check whether or not that command is going to be usable. Now, we can do this pretty easily. A button, for example, has a command property, and we can bind that to a command on the view model. Now the problem is, as you'll see in just a minute, only the button and a couple of other base classes, such as a checkbox, for example, they have the ability to do commanding. Now there's a lot of other things that don't support commanding out of the box in Xamarin.Forms, which is a big problem actually. So because then you would not be able to decouple, for example, an item tapped or an item selected in a list view with a command on the view model. And you have to be able to do that, right, without going, again, to code behind. And if you have to do that, we'll have to look into something called a behavior. A behavior, if you think about what is a behavior in you as a person, it's something that describes you. Right? It's a functionality of you as a person. Well, the behavior in MVVM and the behavior in Xamarin.Forms, and it's nothing really specific to Xamarin. It actually also exists it existed already in Silverlight, even in Windows Phone. Behavior is really something that we can add onto an existing control. For example, onto an existing list view, we can add behavior that will allow us to add extra functionality without changing the original class, so without changing the list view. It's basically allowing us to extend the functionality of something. Now, maybe thinking, what does this have to do with commanding, in essence? Well, the thing is, we can we can write an event. So we can write a behavior that we can attach extra code to that behavior then, and we can actually link an event in the UI with a command in the view model through a behavior. And there's actually behavior called the event to command behavior. And if you think about it, well, that's probably what we need. We need to be able to link an event in the UI, just any event in the UI, with a command in the view model. And we can do that using behaviors. Now, there is on the website of Xamarin.Forms, they have implemented this event to command behavior because it's not built into Xamarin.Forms. It's something that we need to add ourselves. And we can actually use that to link the two together. Now, instead of showing it here, let us go back to Visual Studio and see how we can work with commanding. So for simple things, commanding does work out of the box. For example, let us jump to the login view model. I wasn't able to show you the login screen because I already set it up so that I didn't have to do the login. But here you see, I think you can imagine what the login screen looks like. A couple of buttons. And here you see on the login view model, you see a sign-in command, a register command, and that sort of thing. So that is going to contain the functionality that we want to invoke when, for example, a user clicks on the login button, right? So that is the operations that we have on the view model, in this case, the sign-in command. If we go back to the login view in this case, so let's go back to the XAML layer, you will see here, down here at the bottom, lots of code here, sorry for that. I have to do a lot of scrolling. The login form, that's where we need to be. We have all the way down here, the login button. There we go. By the way, this is implemented as a grid that we can click on. If you want to click on a grid or a stack panel, you can actually do it with something called a gesture recognizer. Doesn't really matter. I have here the command property, which is then going to invoke that signing command. That's what you see here. So then basically, again, through data binding, I will be able to invoke code on my view model. That's actually what I wanted to achieve. Now, I have a problem with, for example, my list view. If we go back to the catalog view, and we are here in the catalog view, and we would like to say here, when I click on an item in the list view, I want to also invoke a command which lives on the view model. But as you can see, as I start typing, I get no IntelliSense. Now, getting no IntelliSense does happen quite a lot in Visual Studio nowadays, with Xamarin at least. But this actually is because this property doesn't exist. It doesn't have a command property built in. So that's where these event-to-command behaviors will come in handy. So that's what you have here. So onto the list view, we have, so every control has a behaviors property, and we can add behaviors onto that. And the behaviors is just a collection that we can add the behaviors to. And in this case, we are adding the event to command behavior. And the event to command behavior allows us to link an event, in this case, item tapped, could be item selected as well. And it's going to be linked with the command that we have again on the view model, which is in this case the add catalog item command. The event to command behavior is a behavior that I professionally copied from the Xamarin.Forms website. So there we go. That's the event to command behavior. So the event to command behavior is in fact inheriting from the bindable behavior, which is in turn inheriting from the behavior. And it allows me to pass in through a couple of attached properties. What is going to be the event name through an attached property? What is going to be the command I want to invoke? And then it contains code that actually links the two together. Again, this is nothing that you have to write. You only have to write it once, or copy it once, let's say in this case, and then you can actually continue using this. And it gives you the ability to just link any UI event with a command on the view model. And we are still good because we're still having loose coupling built into our application, which is good because that's what we want to achieve. All right. Hope this is all still clear. It does go a little bit fast, but we do not have that much time. People in Czechia are a bit in a hurry, I think. Only 50 minutes for a presentation is not a lot. So, all right. So, going forward, there's one big problem at this point. We have views, we have view models. How do these two know each other? Now, that's a good question. We want to get loose coupling. We want to make sure that everything can be easily interchanged and can be unit tested. But at some point, you're going to be in a situation where you're going to have to link the view and the view model. They have to know each other, right? So we're going to have the view and the view model and the model. And if you think about whom is going to know who, well, actually the view needs to know about the view model, probably, because it needs to know what am I going to be data binding to. And the view model is also going to, in turn, know about the model. Well, it's okay to have one directional or unidirectional errors. As long as you don't start creating bidirectional errors, you're pretty much good, because then you can still easily mock things out when you're writing your unit test. So that's still okay, I think. Now, that's the theory. How do you implement this? Well, you can do it in a couple of ways. When doing MVVM, you can actually do something called a view first approach, or you're going to do a view model first approach. Both actually work in Xamarin.Forms. In fact, view first is easier to implement, because then the view will basically ask or search for a view model and use that as its model, basically, in the data binding scenario. You can do it in a very ugly way, which is this, where you, for example, specify a page, you specify its binding context, and you specify that to be its in this case, the login model to be its model, its view model. That's okay, but the problem is you're actually, again, coupling things quite tightly together, which I don't really think is an okay way to do it. You could also, in fact, do this from code behind. That's what you see here. We have the view, and then we have the binding context property set to a view model. Now you'll be thinking, hey, did you not say a couple of minutes ago that it was not okay to write any code in the code behind? Well, I did say that, but I meant, and I actually said it that way, that we are supposed to only write code that does stuff with the view and not with the model inside of the code behind. This is actually, it's using the view model, but it's not doing anything with the data model. So that's still okay to do. Now, while this works, I'm not really a fan of this, because I do think it still ties things way too tightly together. So I prefer to put another layer of indirection in between. And that's why I typically use something called a view model locator. As the name implies, well, this thing is going to locate view models. I think that's rather obvious. So what you're going to have is that you're going to have all your view models register with that view model locator. And on the other hand, you're going to have your views, and they know about the view model locator. So the views are going to talk with the view model locator and going to say, hey, I need some view model. And the view model locator is going to say, oh, I have this for you. Here you go. And hopefully this already starts making you think, well, we're going to need some dependency injection in there. I'm going to come to the dependency injection part in just a minute, but it does actually have to do with dependency injection as well. All right, going back, so I'm going to do things separately. So we're going to see first how the view and the view model are linked together. Now let's take just any view. Let's take the login view. All the way at the top, you see this line here. It says here, view model locator dot auto wire view model is set to true. It does say view model locator, so I think it has something to do with what I just explained. So let's take a look. We have in the base view models property folder, we have this view model locator class. Now this is actually a bit of a weird way of implementing things, but it actually does work pretty nicely. So this is a class which defines an attached property called AutoWire view model. That's the one that you just used inside of the inside of the view, and it does contain this on property changed method, which is called in this case on AutoWire view model changed method. This method will be invoked when I set this property from the view, right? So this method will automatically be invoked on this class when I actually invoke or when I set this property in my view. And in there, what we are going to do is I'm not going to show you all the code, but if you look at this from where you're sitting, actually from distance, you will see that it looks in the class, so it gets in the view. Yeah? The bindable object, the bindable object that you're getting in is the view. And the view is going to be, we're going to ask the view, hey, what is your full name? And I'm going to, in there, replace the view part with view models, right? And then we're going to, through, in this case, through dependency injection, I'll come back to that in just a minute, we are going to get the actual view model type. And the view model type is there at the bottom, going to be set to the view binding context. So in other words, we are going to dynamically resolve the name, the type of the view model, and set that as the binding context for the view. And that's what we are going to do here. So again, we're still having loose coupling being used here. So the view binding context knows about its view model in the end. That's actually what we wanted to achieve. So if you look at all the views, basically, for example, the catalog view, they do pretty much the same thing. So all are going to basically invoke that one line. That's going to go out to that attached property in the view model locator, and that is then going to search dynamically for the view model type, set that as the binding context for the view, and there we go. Everything is again loosely coupled. Now, you may have seen one line here that I haven't, that I really skipped over, basically, is this thing here. The container.resolve view model type. Well, that has to do with dependency injection. Well, there is actually dependency injection going on. If you look here, I assume everyone is more or less familiar with dependency injection. Basically, getting the dependencies being injected in from the outside instead of doing them directly inside of the class. Again, helps us with loose coupling, which is what we wanted to achieve here. Now, in this case, this example, if you go a bit higher in this view model locator class, you will see here that we are using tiny IOC. You could use just any IOC container that works from Xamarin.Forms. This is using a tiny IOC. In the previous version, by the way, they used autofac. They changed it at some point. But in any case, this container is being used here inside of this view model locator. I tend not to do this inside of this class. I tend to split it out a little bit more, but anyway. But this thing is going to do, we are going to start the view model locator as a static constructor. So that's going to be invoked very early in the execution of the application. So we're going to register all our types. So we're going to register all the view models. We're going to register our services. We'll come to the services in just a minute. And we also have down here a little bit below, we have this resolve method. So we're not using the IOC container throughout the code. We're only going to use this class, and we're going to use that class to actually resolve things instead of spreading the IOC container throughout your code, which is of course also bad practice, because then you create a dependency on your dependency injection container, which is not a good thing. So we are going to wrap everything nicely inside of this class. So we're going to ask, in this case, give me a certain type, and ask the container to resolve it. So that's basically what we're doing here. If you look at the view models, so everything is now nicely registered with the container. If you look at the view models, for example, the catalog view model. If you look at the catalog view models constructor, you do see here that it is using it's getting in an iCatalog service. And we haven't talked about the service, we'll do that next. But we are using the iCatalog service, which is going to be injected in because it's known by the dependency injection container. So that is going to dynamically get injected an instance of the product service class. And that we are then going to use. If you scroll down a little bit further over here, we are going to use the product service to talk with the model. So getting data asynchronously is what we're going to do here. So we're using that in a dynamic way. Now we are also using, you can't use the dependency injection stuff, so the constructor injection stuff all the way through the application. There's places where you can't use this. For example, one of the places where we have to use things a bit more in a forced way, let's say, is in the app class. In the app class, we are using we are going to use the settings service and also the navigation service a bit further, down here at the bottom of the screen. And in this case, we are using that resolve method, passing in the type we want to retrieve. So we are basically not using dependency injection here because that doesn't work on the app class. So we are going to use the view model locator.resolve method to in this case, resolve through the dependency injection container, the navigation service and the setting service as well. And in this case, we are then going to use those to start the navigation and basically start up the entire application. All right, so I have skipped on this part, so let's go here. All right. Now, the basic promise that I made you in the beginning, I think, is we're going to make a testable and maintainable architecture, right? So what we want to achieve is loose coupling. And if you want to have loose coupling, we want to make sure that everything is easily mocked out. right? And it also applies for the view models. Because for the view models, you're going to have a lot of view models in a real-life application. This application is not that big. It has like 10 view models. So you're going to have a lot of view models. And those view models are going to be, let's say, tightly coupled if you don't watch out. Why? Because view model A is going to talk to view model B, and B is going to talk to C, and so on and so on. And you're going to get a spaghetti of hard-coded, of tightly coupled view models, which is not what you want, right? Because then all the work that you've been doing up until now is basically wasted, because everything is going to be tightly coupled again, and on the view model layer, it's going to be hard to test things in separation. So we're going to, again, introduce another layer of abstraction here, and we're going to make sure that the view models can communicate with each other, but don't do this in a tightly coupled way. And we can do that using, in this case, a messaging platform, a messaging center. Well, the messaging center is actually a messenger which is built into Xamarin.Forms, and it allows us to have multiple view models to talk with each other in a loosely coupled way. And that's what you see here. We have a view model here on the left, and we have a couple of view models on the right. A view model on the left needs to talk with the view models on the right. Yeah? How can we do that? Well, view model A, so the one on the left, it will register itself with the messaging center. And it's going to say, well, I'm going to be sending you some messages. It's basically using a pub/sub model. Yeah? And view models here on the right, they're going to talk with that messaging center initially, and they're going to say, well, when you get in a certain type of message, do let me know. So basically, when the one on the left sends something to the messaging center is then going to broadcast that with all the registrations, basically, and they're going to be notified about this change happening. This is actually a nice way of letting my view models communicate in a loosely coupled way. They don't have to know about each other, but they can actually communicate with each other. And we are using, in this case, the built-in messaging center that comes with Xamarin.Forms, which might not be the perfect thing to use. It actually only supports, it is based on strings, so it might not be the perfect thing to use, but it actually does work. You can actually use your own messenger as well, but in this case, I'm using the built-in messaging center. All right, so let's go back to the demo. And one place where you have this, for example, is when I add a product to the basket, I want my catalog view model to notify the basket view model about this product being added to the basket, right? That's what we want. And we don't want to have the view model directly instantiate the basket view model, because then we again create a tight coupling between the two. So what are we going to do? Let's take a look at the catalog view model over here. And as you can see here, when we add an item to the catalog, when we add an item to the basket, we are going to use this line here. And we are using the messaging center. That is the built-in, as you can see, it is using the built-in Xamarin.Forms messaging center. And we are going to send a message, and we are using a string. Message keys.add product is actually a string. And we're going to specify also the catalog item that we want to send. So we're going to send that into the messaging center. On the receiving end, and that would in this case be the basket view model. In the basket view model, that's over here, we are going to register, we're going to subscribe in this case, that's the method that we have to invoke for that, messaging center.subscribe, and we are going to pass in this case, that we want to be notified when the catalog view model notifies us, and we are getting in a catalog item. And the string is actually that same string as we sent on the other side. And then what we want to invoke is this code, which is then going to talk with the services to add that catalog item into the basket on the backend. Loose coupling, that's what we wanted to achieve, and it seems to have worked here as well. All right. One thing that we haven't talked about, and I am a bit behind, so I need to speed up a little bit. One thing that we haven't talked about yet is navigation. Now, when you start building applications based on MVVM, you see a lot of people getting confused with navigation in MVVM. Basically, because of the fact that MVVM doesn't support anything out of the box for navigation. It really doesn't have anything to do with navigation. Now, the thing is, I said earlier that my view models have two tasks. They have to expose state and operations. Data, things we want to invoke, the commands. But it's actually a third thing that the view model will need to do. And that is also making sure that we have a good flow within the application. Because if you think about when I click on something and I want to navigate, where are you going to put that code? Typically, you would put it in code behind. That's not what we're going to do anymore. So now we need to, it is going to be the view model, let's say, that needs to know, or that will say, well, now we need to navigate. Now we need to do this, or we need to do that. So the view model is actually doing a third thing, and it is making sure it's the manager of the flow of the application. right? But on the other hand, view models need to be kept as dumb as possible. We shouldn't actually introduce any logic that knows about how we can do navigation in the view models, because then again, you make them dependent on UI code. And if you see them being dependent on UI code, you're actually doing it wrong. So we're going to have to introduce service classes that do one specific task and one specific task only. And navigation is actually one of those. So how can we do navigation? So instead of talking about it here to save us some time, let's go back to the Visual Studio. And how do we do navigation in this application? Well, if you look in something in another folder that we haven't explored yet, which is the services folder, you will see here navigation. Right? And it has this interface called iNavigation Service, which is registered with the dependency injection container. And then we have the navigation service class. Now this class is actually quite a big class, but it does everything that has to do with navigation. So it has methods, maybe we should look at the interface, that's easier. So it has methods like navigate to async, passing in a view, a view model that we are going to navigate. We can do a remove from the back stack, we can jump back. So all the basic stuff around navigation is wrapped inside of this service class. And that's what you see here. We have the actual navigation service class, this one. And it implements this interface, of course, but it does have dependencies on view stuff because it does navigation. So it really has to know about stuff that we're doing with the UI. This is not code you should be placing in your view models. This we place in one class that does just this. And that's what we want. Now, the core of this method actually is inside this internal navigate to async method, which contains logic that is going to do navigation and push pages on the back stack and that sort of thing. But it also does one thing. Remember that I said, on the base view model, we have this class called, this method called initialize async. Well, actually, this is where this class is going to, sorry, this method is going to be invoked from. We are actually going to do the navigation, and then when we have the view model, which is a view model base, we are going to invoke that initialize async method. That's a virtual method on the view model base, allowing me to do lazy loading of my view models because all your view models are registered as singletons in the container. You should not load any data at startup. You should only load data when you actually navigate to that view model. And that's what we have achieved using this initialize async method here. So in this initialize async, for example, if we go back to the catalog view model, this one, we're actually going to over here, initialize async, there we go. In the initialize async, we're going to lazily load, let's say, the data from the backend. Then we are invoking, in this case, the product service, which is going to then get the data from the backend. And that's what we do. That's a good way of doing things. Yeah. Now, that product service, now that we're talking about that product service is actually going to be the way to talk with the backend. Right? If you look at the product service, if we do an F12 on this one, and we go to the implementation of this one, and the product service, the catalog service, is actually going to, for example, if we use get catalog async, that's a method that is pretty easy. What it's going to do is going to get me products. It is going to go out it's going to use a REST service to get its data. That's what we're going to do here. Now, this is not implemented, in my opinion, in a perfect way, because this is a service class as well. It does just one thing. It gets data. This is data service. Again, that's not code that you should be placing inside of your view model. It's code that you place in a separate service class that is this catalog service. And it is going to talk with, it's going to use this request provider. Now, the request provider is actually, sorry, this one. Go to implementation, this one. The request provider, you can see that as your repository layer. That's the one that goes out to the real, actual web service, passing in a GET request, putting up, setting up the HTTP client to do that. So that thing we have actually abstracted out in this particular class, the request provider. This get async method, that's the one we are using. It is going to use the create HTTP client method first to set up the HTTP client, passing in headers, passing in stuff like tokens and that sort of thing. So that we are doing here. And then, going back up here, over here, we are that's the post, sorry, this one. We are going to use the HTTP client, so it's the Microsoft, the SystemNet HTTP client that we're using here. Then we are going to get data asynchronously of course, asynchronously, and going out to the web service. We're going to get in the HTTP response message that we're going to pass using, so we're going to read that out over here. And then we are going to pass that using JSON convert, so JSON.NET is going to be used to deserialize the object that we got in from that actual web service. And that's how we get the data inside of our view models. Again, it's nicely separated. We don't put this code directly inside of the view models. This is code that we place directly in these service classes, the data classes basically that we have to use for that particular thing. Now, this is a nice bridge to the backend, and we don't have that much time for the backend left anymore. So let me jump a couple of things here. So we now see, we have talked with the backend services. We're invoking backend services. And the backend services in this case are being implemented using .NET Core. And I think by now everyone is more or less familiar with .NET Core. Why is this important that this is .NET Core? Well, in fact, for this type of application, it actually makes sense to set this up as a microservices architecture. And that's where .NET Core really shines, because .NET Core allows us to build more lightweight backends, lightweight services that we can much more easily scale out and set up in a Docker container or in a Docker setup. So ASP.NET Core is what is being used here. Lightweight services, also cross-platform, so we can use this on Linux servers. So again, making sure that the footprint of these hosting platforms is smaller. Now, .NET Core we're not going to talking about here. That's not what I'm going to talk about. So basically, what I'm going to use here is, like I said, containerized microservices. Now, if you look at backends that we have been building for a lot of years, we've been building 3-tier architectures or whatever. And the problem, although people have been saying, well, this is how you should be doing things, if you think about your tiered architecture, that is still one big block of monolithical code. Right? You have your business layer, you have your data access layer, but it's physically not possible to say, well, I'm going to take my data access layer and put that on a different server and then have my business layer spread out because I have much more load on that. That's physically not possible. Because although you have been spreading out things for many, many years and you think you did a good job, and you actually did a good job, but it's not really scalable in a cloud-based era that we're now we're living in. It's not really possible to spread things out as we'd like it to be, because the code, although it's tiered, it is still a one monolithical block of things. Right. So in a for cloud readiness, that's not typically what you want. And an enterprise application such as this one would actually benefit much more from a microservices architecture. And if you do it in a plain tiered architecture, you're going to be stuck in this scenario where you have your setup and your application is nicely tiered, but all the tiers are are basically tied together. And if you want to scale out, basically what you need to do is you need to bring in more service and copy the entire application onto multiple servers. And that does work, I know, but it might not be optimal. If you do this, if you use this approach, it's going to cost you more. Because if you think about it, it might be that there's going to be more load on your catalog service, because a lot of people are browsing your catalogs, but not actually buying. So there's going to be much more load on the catalog service instead of the basket service. So it might make sense to actually say, well, I'm going to spread out the functionality that is hosted inside of the catalog. I'm going to spread that out over multiple servers and use or scale that out, and the rest are going to leave as default. And that's where microservices architecture is going to be a much better fit for this type of enterprise applications. It's going to make this approach much more simple to create. Might not actually always be that simple to create, but it's going to also make it more scalable as well. It's going to decompose the application basically in several components. So instead of having what we just had, we're going to have this approach, where we basically take our different components and scale out, for example, only the catalog service. So that if there's higher load on this catalog service, we can more easily scale only the load on that catalog service out onto multiple servers. Yeah. Scaling can also be instantaneous. So there's a lot of things in Azure that make it possible to scale this out in a very easy and much cleaner way. Now, microservices, what is a microservice really? Well, a microservice is like a mini application. It's a part of standalone functionality in your application. In this case, the catalog would actually be a nice microservice. The basket is a nice microservice. they are standalone functionalities. And it might not always be that easy to think about microservices in your application. This is a simple approach. It's a bit of a classroom example where you nicely have that functionality of the basket, the catalog, and that sort of thing. It's not always easy to split things out in a real-life application. But you should think of microservices as being standalone functionalities. And they are standalone applications, even with their own database and that sort of thing. And they, of course, need to communicate, and that's where a service bus typically comes in, because then the different microservices can talk with one another, put messages on that service bus, are going to be picked up by other microservices. There's a lot of benefits with building an application in a microservices architecture. Think of evolving things in a different fashion, in a different way. In your application that is monolithical, if there is one component that is not upgradable to .NET whatever, well, then basically your entire application is stuck with the fact that one thing can't upgrade. If you spread things out in microservices, well, if there is still a dependency on an old version of .NET, you can leave that one microservice in the old version, and all the rest can evolve. Also, if one service goes down, it doesn't bring down the entire application. You can much more easily isolate a faulty microservice and make sure that the entire application doesn't go down. There's a lot of benefits, but like I said, there's a lot of benefits, but there's also a lot of downsides. It might not always make sense, or might not always be easy to say, well, that's a microservice, that's a microservice. Splitting it out can be a bit of a challenge in most cases. There's a lot of, well, yeah, in theory, it all makes sense, but in a real-life application, it might not always be that easy to see. Also, the communication between microservices might also be a bit of a problem. There's other things that come into play, such as eventual consistency, because if you have different databases, because each microservice typically has its own database, they actually might need to not always be up to date in terms of data, and that's where eventual consistency comes into play. I don't have time to talk about all that, but that's basically things that you have to look into before making the decision that microservices are a good solution for your application. I'm going to show you the microservices in just a minute. In this case, what you're going to see is that they are going to be deployed in a containerized way. Containers, I assume that you also heard about it. Quite a few presentations on Docker here and Docker containers as well. So containerization is basically a technology where we take the application, its dependencies and its environment, and we put that inside of a container, stack of containers, and we can easily take that entire stack and scale it out onto multiple servers. Well, in this case, we're doing that here using Docker. And to make sure that we don't go too much over time, jump back to Visual Studio, okay? And let's take a look here. So we are now in this services part. Well, if you look at the services, for example, the catalog API, there we go. The catalog API is just a .NET Core API, nothing fancy. It's just a plain API. It is doing just the functionality for the catalog, and nothing more, nothing less. So we're just doing that. It has just plain controllers. It has this catalog controller, this one. And that's actually the one that we were invoking from the services application, or the services block inside of the Xamarin.Forms application. So it does, in this case, get a couple of items. It gets in a page size. It gets in an index where it should start. And it just goes out, fetch some data, return that data. It has its own database, so it's standalone applications. You can use this for multiple applications even. This is a typical microservice. In this case, it does also come with a Docker file. And a Docker file, in this case, explains how this application should be, let's say, stacked in its containerized environment. How does this application run? What does it need under the covers? Well, it might need SQL Server, it might need an ASP.NET Core environment, and that sort of thing. So that's all wrapped inside of this Docker file. And then at the bottom, so basically, if you look in the, if you explore this further, so all APIs are pretty much the same. So all of these are my microservices blocks, my building blocks. Basically, all of them are small microservices. And then that entire thing is described in this Docker orchestration file, which is one file that's typically used for the deployment of the entire environment. And that describes all the microservices and how they should be used in combination, how they should be deployed, and that basically orchestrates the entire deployment. So that's how Docker can actually help us to set this up in an easy way to make the deployment of this much easier. So we are out of time, sadly, so I cannot go any further into any detail here. So I hope that at this point you have a good overview of how a real life, because this is actually how I build my applications as well, a real life application in Forms can be written. MVVM is really the way to go. It makes sure that you have nice separation of concerns. It makes sure that the application becomes much more testable, easier to maintain in the long run. If you want to start exploring with microservices, start thinking of how you should actually, or how you could actually split up your application into multiple standalone parts, and then of course also take a look at Docker to make to understand how you can much more easily deploy all these in a containerized environment. I want to thank you for being here. If you have any questions, feel free to ask them now, and enjoy the rest of the day. Thank you.